Good afternoon, Professor. This is my seventh assignment of IPD MMIC. Topic of this assignment is challenges and future in IPDs, and it has further subtopics like IPD challenges and futures of IPD. This is the content of the table. Now, this slide is about the challenges and futures in IPDs. What were the challenges and what will be the near future research will be going on. First of all, IPD has developed to replace a of bulky discrete passive component, and it has grown industry and derived by RF, high brightness LED, digital mixed signal application, and it has major challenges also for circuit designing that also include integrating passive in same system, low cost time saving process for fabricating high performance device. It is accurate simulation and verification can reduce the expensive of design cycles, and this size also die size shrink and the device layout become very component. The conventional circuit design approach that uses a simulator with a plumb component library models can also no longer accurately predict so the performance of fabricated device. Now the product design which has use only this circuit simulator, many cycles of design, fabrication and redesign and refabrication. This process sometimes does not result in satisfactory product performance. And what was the first part was like introduction and some basics challenges and near futures, uh, but this slide is about the IPD challenges. What are the main challenges we have? uh, as the realization of high performance spiral indicator is another challenge in IPD design. Inductor is needed is like meet the inductions Q factor requirement, minimum amount of capacitance, highest self resonance frequency. Many way to enhance is this Q factor of monolithic inductors, like electromagnetic coupling between the inductors can complicate the RF circuit design and layout. Insertion loss can reduce by increasing the inductor spacing. Limitations of gas-based technology. Performance of microwave passive network. High level of harmonic rejections. An advanced passive integration technology can improve degree of integration. Simply simplifying the assembly is high desirable for RF and microwave applications. So this is the futures of IPD. The means what trend in technology and industrial, and what will be the roadmap for the new future IPD technology, and what traditional means what trend industrial will adapt for this technology. So in this you can see the scale of frequency ranges from 1 to 10, and it has a micrometer of 50, 25, 10, 1 micrometer, and discrete passive lies at 1 frequency, and the 2.5 G and 3G at 2 frequency. Bluetooth lies at the range of 3 frequency at the range of 3 frequency, and WLAN lies at the range of 4 frequency, and WiMAX lies at the 5 frequency. So the Japanese player like LTCC it has a certain this players, and the IPD players are Philips, Siemens, and Philips MD in house uses, and Siemens in house uses, and again set chips pack is a design house, and free skills is a DM in a house use. So this so it has a, it's like and the next graph is about at what range, at what year uh, the we will grasp the trend of this technology. So it's about like this, and I will explain more detail about this figure in the next slide. So in this undertaken of enhancing and increasing, as I said, the challenges, and what were the challenges and requirement, and near future goals were that first of all, the performance and yield, and possibility of integration of large number of passive component to design in such a way that it integrate very easily, and to design and fabricated passive device onto GAS substrate of wave application to develop a more mature IPD fabrication process in order to obtain a higher capacitor density at a lower manufacturing cost, to develop a much easier and more compatible IPD fabrication process for utilization in commercial industry, and to develop and study RF and microwave left-handed material based on the GAS based substrate, to build up some new high performance modules with complex layout using double uh, average structures. So all these points is about the what are the future goals, and how, what will be the difficulties will come to achieve these goals, and what the challenges will come to achieve this type of technology. So I have studied in this assignment in near future what will be the goal, and what will be the challenges about this IPD, to design this kind of IPD, and yes, that's it. I have studied in this assignment, and in further assignments also I have chapter wise I have gone through many more thing, and it was very informative, and thank you for this assignment, and I have studied a lot, and it is really very good subject to study about. This is the good book also, and to study about more and in detail if you want to go through. So I think this was the nice assignment and very informative. Thank you.